So welcome to the session of the Fragile Art of Edge Computing, walkthrough access control systems. My name is Philippe Lin. I'm presenting along with Roel Reyes. This research is delivered by our colleagues, Joey Gostoya, Vincenzo Ciancaglini, and Dr. Morten Swimmer. All of us work in forward-looking threat research team in Trend Micro. So feel free to drop us questions on HITB Discord channels. My colleagues and myself are answering the questions here. Okay, so edge computing does not come out of the blue. The arrow above illustrates the history before edge computing. And for example, we had standalone nodes were later connected with LAN, local area network, and they were gradually connected to the internet, the cloud, and then back to the powerful on-premise nodes, that is edge computing. And you could say edge computing is the history repeating itself, because the edge nodes are now responsible for protecting your data, just like 2 decades ago. And vendors chose different types of edge computing models. For example, industrial control systems has improved the cellular routers to edge gateways, and the fleet's shop floor control uses edge gateways, and for facial recognition systems that needs higher bandwidth and faster processing speed, they chose edge servers. And if you are using a very powerful tablet, then that's a powerful IoT lens per se. And using edge computing nodes means there are several advantages. For example, that's on-premises data acquisition, which means that the data is collected on the edge and it doesn't leave the premise. For the applications such as smart healthcare, the data should not leave the hospital in order to comply with HITB. That's why edge computing kicks in. And it provides some sort of resiliency. For example, you want the system to be still running, even if the network is temporarily not accessible. And resiliency means that the edge node gateway servers are autonomous to some extent. They have lower latencies, since the data are processed on the edge, and since there's no more traffic back and forth to the data center, that means less traffic and faster network traffic. So here's also where we want to exploit, because some sort of resiliency means that you have to trust the edge nodes to some extent. And this page gives you an overview of the edge computing architecture. We have copied it from a white paper. The link is given at the bottom of the slide. So on a normal scaled system, you might find a 3-layered model just like the one on the left. And on a larger scaled system with more nodes, that will be a 4-layered model, just like the models on the right. And you see like smart assets, smart sensors, smart controllers, actuators at the very bottom. And the data they have collected is sent to a smart gateway or edge computing node in the middle. And the matrices are some control data, some audition data, logs are sent to the data center. That's on the very top. And 3-layer model or 4-layer model, they are not pretty much different because it's just like a horizontal expansion of the system, just to handle this a little bit complexity introduced to by more nodes. So so what has motivated us to look at access control system? So shortest answer is that our company was testing such a system in our offices. So it's easier to acquire devices. Somebody has bought them for us, and we don't have to pay extra. And so before COVID-19, people were only testing the edge computing system for the future. But since the breakout of COVID-19, body temperature sensing is more and more important, and it's advertised even as safeguarding the city. Just like the screenshot you see above, It shows a facial recognition system that's used in Beijing metro system. It does some sort of facial recognition as well as measures the body temperature on the fly. And a little bit disclaimer is that we did not test this product. This picture is there just for a very good example.
Hi everyone, this is Roel. From this research, we tested 4 devices and compared its security and communication protocol. So the first device that we had our hands on was the ZK-TECO. So that's the Face TPS980. We have this in our Manila office, basically. So ZK-TECO is one of the biggest Chinese vendor that supplies access control devices. It's basically sold 3.8 million just for the fingerprint reader alone for last 2015. It's an Android-based camera as well. It uses MACD algorithm and can store up to 10,000 faces, images, basically. It also has the feature of checking liveliness, and it can communicate with different I/O relay like the Wagon RS232 and RS485. During our research, we were surprised that the only face image are stored and not the actual metadata for the facial recognition thing. The next device that we had access was the Hikvision. It's a DSK1T606MF. So it's a combination of facial recognition, fingerprint, and RFID checker. So Hikvision is one of biggest vendor in the world that supplies camera and access control as well. It uses a customized Linux operating system. So basically, we managed to check the device, access the communication in between. But since we are still doing some decoding for the actual binary data, so we were not going to talk about this device on this presentation.
Okay, and this one is a Telpo TPS980. Actually, we bought it for fun. So Telpo TPS980 is Telpo is a partner of Alibaba. They provide a facial recognition service for a point of sale terminal of Alibaba shopping centers, and it uses ArcSoft facial recognition algorithms. It's a very common algorithm used by many devices. It's Android-based camera, and actually that's a standalone camera itself with an optional cloud service for $10 per device per year. And by standalone, it means that this camera has this tablet has a camera attached, and when it does the facial recognition, it matches the database stored in the tablet. And when it matches one face, it opens the door by shorting the digital output and input pin. So for bigger businesses, there's also an SDK only version sold to the customer. So for this algorithm, one has only to pay $38 and it has LTE and the vegan and the digital I/O interfaces. So this one's really cool. And then we have a product from vendor A. So this product is bought by a very big Chinese company. It's actually one of the top 3 facial recognition companies in China. It's marketed as a residential access control system. So the use case is to deploy it in the basement of several apartment complexes. And it has a very high throughput. And when someone passes by, it takes a snapshot and sends it back to the edge server for audition. That's why it needs an edge server instead of just do everything on the tablet itself. We have bought the on-premise version, which means we have paid more money, and the on-premise version has brought us some really good advantage of having HTTP instead of HTTPS connection. And it works with network relays. So it's network relays that you can buy on the market.
Okay, so let us talk about ZK-TeCo, our findings with the devices. So ZK-TeCo device is based on Android OS. Basically, it's Android 5.x Lollipop. So there's a USB port on the lower part of the device. Basically, it's used for importing and exporting records. You could also do ADB connection on the USB, but unfortunately, we didn't do more testing on the ADB connection, but we concentrate more on the communication protocol. In this slide, it shows us a general infrastructure setup of ZK-TeCo. So user register from the device updates or sync its information on the server, and then the server syncs the information across all the other devices. So information like password, PIN code, crop images, facial biometrics, and door access are synced on those devices. From our test point of view, we just used the user registration device and the server itself. So what are the things that we've done? So in the initial test, what we did was capture communication protocol or packets from the device and server. So first, we used MITP proxy since we assumed that the communication was HTTPS, but unfortunately, it's not. It's just using HTTP and it's in plain text. So second, we use Packet Squirrel to monitor a data traffic. So we embedded the packet sniffer on the server on the device, which communicates on the server. Okay. So lastly, we perform Wireshark on the test environment we have. So from the collected packets, we analyze the protocol and data or the payload. To our surprise, things are not encrypted. So everything is in plain text. So what's next? So the important part there is you have to first identify the serial number of the device. So on the communication or on the Wireshark or on the packet itself, you could identify that. Looking at the image on the slide, you have their SN with the serial number on it, and a token, which is used by the communication from the device and the server. But unfortunately, you could just use or reuse the same token. And we've identified two communication: server going to the device and then device going to the server using port 8088. So let's try to check the findings that we have by using or presenting some demos. Okay. So on this first demo, let us try to add a new user with normal permission using a simple curl command. Okay. So looking at the payload, it contains table UID, card number, PIN, password, group, start time, end time, name, privilege, disable, and verify. So those information, you could actually put anything on the UID with the just numbers on it. PIN is something like the ID identifier for the user. Password is in plain text, so I just put there 1, 2, 3, 4, 5. Group 1 is the default. Start time, end time, 0 is the default. Disable and verify is 0 as the default. Privilege 7 value means it's a normal user. Okay, it's a normal role basically. So let's look at the demo. So here on the demo, if you look at the UI, there's one personnel, Angel. And then when I execute the curl command, then go back to the UI and then refresh, then there you go. You have 1111 bogus name with a role of ordinary user. Okay. So from there, you could actually create any user with any name, or if you identified some legit name, then you put that there. Well, anyway, you were able to create the user, but it's just a regular user. Can we create an admin? Yeah, we can. So adding an admin or modifying a existing user with an admin privilege, all you have to do is just change the privilege to 14, and then do the same execution, curl command. Let's look at the demo. On this demo, I've just created a new user basically. So same payload except for the privilege, it's 14. It means it's administration role. And then try refreshing the UI, and then there you go. Checking the operation role, it's administrator. So that's easy, right? Now we've created a user with an admin account or admin role. So still it's looked like a bogus account. So we can actually insert a user profile. How do we do that? So by changing the query parameter from user to user pick and replacing the payload information. So here's the payload information. So there's the table name, user pick, PIN, which is the PIN number that we used a while ago when creating the user. Size is the actual size of the binary file or image. Content is the basic cipher conversion of the image. So you might ask if there's a resolution or size limit on the image. To answer that frankly, I haven't really tested that. All I did was use the one I've seen on the packet sniffer. It's 720 by 1284. That's the size. So let's try this. So looking at the bogus profile, that's the avatar, my avatar. So let's try changing it into a more realistic user profile. So here's the curl command with the payload. After executing, let's try to refresh the user UI and then look at the new user profile. So that's it. It's a user profile of one of our colleagues. It's Vincenzo. So we have the profile, the account, the password. So can we use this on the device? Well, yes, we can. If the server actually finish the sync up of the information from the server to the device. But we don't have the facial recognition information. So how do we insert that information? So from here, we can change the biophoto. Well, biophoto means that the facial recognition schematics or the information. Like what we said, we're really surprised that it's not storing the actual schematics, but it's storing the image itself and then perform the algorithm. So here, we use the biophoto table name, okay? And then here's the payload. We change the table name to biophoto, use the same PIN. File name is the PIN with the .jpg. Type is 4, which means it's a JPEG. Size is the actual size of the binary file. Content is the basic C4 content of the image file. So I've tried testing a couple of images while I'm doing this research. So I've tested the Totoro image, a sculpture image, and Jollibee. So out of 3, the only image worked was the one in the middle, the sculpture face. How come? So it's actually checking the eye formation, the cheek here, and the side of the nose, and this part. So it's trying to check that if it's a real person or not. Well, while I was doing that, I printed out this image and then tried it out. It didn't work. So basically, the liveliness algorithm of the device is working. So let's see a demo. So here, let's check on bogus account. So we have we don't have any facial picture registered, right? So let's try executing the same curl, just replacing the payload and the table name. So there, and then let's wait for the server to actually updates its information. Well, you could actually see there that there's none yet. Okay, so there's one. So it's a little, that particular icon there. So let's try accessing it and view the face picture. Okay, so I did that, right? It's the same. So what's next after this, right? So we could actually use this and then update the device, and then you could use your image and then enter any room in a company or an office. Oops. Okay. So there are other findings that we stumbled while doing this research or doing the packet analysis. So we were able to like get some harvesting of the user information, user photos basically. So just using the URL provided on this slide. So the server and the IP of the port of the server, and then upload pers, user, face, and then pin. Just replace the pin with the ID that you could, or just a random number, and then you can actually download the actual file or the actual image. So let's look at the demo here. So let's try. I was accessing the server UI, and then check how many users I have, like 2. So I have the Angel and Bogus. So I'll try to access the pin for Angel. And there you go. So you could actually create the bash script that will scrape all this information. So what else? You could also do user data exfiltration. It happens when the server or the device sync up on each on the client or the server itself. So here's the packet example. So you can see there that there's the pin information, the basic Sephora content or the image, the biophoto that's used, and the authorization. Okay, so you can actually get the name, pin, user image, and facial biometric image. So we've done the device client to server vulnerability or exploit. So here we'll be doing server to device. So what we did, we've created 2 scripts which performs the following. One is it creates ARP poison to acquire the server IP. Second, it replicates the communication of the server to the device. So basically, it sends commands to create user, make it an admin, change the biometric, facial recognition, schematics, and that stuff. So here's a very nice demo about it. So here you can actually see that I've created a demo account, an admin, without the facial recognition. So looking at it, I've just added the PIN code so that I could access the device. So that's the user management. So only have like 1 account here. So that's my alias. Okay, now I'll be assuming that we already gained the server IP by executing ARP poison, since I'm doing isolated network test here with static IP. So from this script, I've executed the zk-techo.py, created an ID 97601 and name, which is I'm just using my name here, and then execute. So it's started to like replicate or create a flash server using port 8088. Since the device is broadcasting the communication on the server itself, so everything starts to communicate. So it triggers the communication of the device, and it creates all the necessary information or all the user information required for the device. So looking at here, we can identify that it was successful by looking at the return code 00 and the command. That's delete, update, update, and update. Okay. So after doing that, I was trying to check if it worked. So let's try. Okay, it was successful. I was able to create my own account. So am I an admin here? Let's try. Okay, trying it again. All right, there you go. I was able to access the actual device and created my account with super administration role. Okay, so it's that easy basically. So let's try if the password was also working. So just enter the PIN number. That's 1, and then password is 12345. All right, so it worked, right? So you could use the PIN number or the password or even the registered facial recognition image. So to cut it short, our findings, we can add user from server side and device side as well. We could change user privilege. We could change user facial recognition data, and we could obtain user information. And also we assume that this kind of vulnerability exists in other vendors similar to ZK.
All right, thanks, Roel. So the next one we have on the list is the Telpo TPS980. So actually, you can find this product on AliExpress for something around $600. And in this section, we are talking about the optional cloud service that is licensed for $10 per device per year. And without the cloud service, users can buy a $38 algorithm license to write their own Android application. But it's cheaper for a big company to write their own applications, while small and medium businesses tend to buy cloud service. And this one is the back of the device, and we see a slot of SIM card here and a bunch of cables, cable with like power, digital I/O, vegans, and you may have not noticed it, but the key to everything is actually printed on the label. So let's zoom in. The label. Okay, so that is the serial number. And with the serial number, you can access everything on the cloud service, just like add a user, delete a user, change admin password, change pictures, make fake attendance logs, dump the user DB, and download the pictures. And however, we want to express our appreciation that actually on the device, the HTTPS is on and the server certificate is checked. Therefore, we have once tried to use man-in-the-middle proxy to do a man-in-the-middle attack, and we have failed miserably. Without adding a fake CA for man-in-the-middle proxy, and that's not easy since Android 7. It's not possible to do such an attack. So we think this is a good practice delivered by the vendor. And apart from the HTTPS secured by Novate library, actually the vendor have used the ProGuard to obfuscate the APK. So it brought a little bit difficulty for us while we're doing the reverse engineering. The only thing they forgot to turn off is that everything is logged in great detail, just like the slide that you see here. For example, when someone draws near, you see the log that someone comes and with its names. And it shows the serial number, the group ID, the access token, everything you need to play back or do a replay attack. And it even shows the HTTP post URI so that you can try to think about it, and maybe we can pretend we can forge the client itself and hack the server. So actually, this gave us a very good idea that if we cannot forge the server, we just forge the client and dump everything. And again, let's recap it. This is the access token on the back. This is the serial number printed on the back, and with the serial number, you can get the access token. And with the access token, you can just log into the server and do everything. We have noticed that the client secret is always the same, but the access token changes every time the expiry time is about 1 hour. We cannot impersonate the server, but we can impersonate the client. And if a guest is registered on the system, we can actually get the guest's QR code and use a QR code generator. You're able to print yourself a badge and just print the badge and log in. And the faces are downloadable with HTTPS GET. So it's a kind of security by obscurity. Let's see a demo. So here we have obtained the serial number from the back of the device. Then we just call the API and get a secret and the device password. And you see here, you get the client ID, client secret, which doesn't change anyhow. And you use the client secret to get access token. The access token is here and it will expire in 1 hour. So once it expires, just come and grab it again. Then with this token, you can tell the backend server that the device is going back online. And you see the code 1 which means it's okay, it's online. Then here you dump the guest users. You get the name, you get the expiry time, the mobile number. So I'm pretty sure it violates the GDPR here. And the QR code. This QR code, just dump it to QR code generator, and you can print yourself a badge. And here you see how to list deleted users. Even if the user is deleted, you can still retrieve it back from the database and get for example, get the faces, get the mobile number, get the names. And even though there is a hash that prevents you from brute forcing, you can just download it, download the face. And with this command, you can add a fake attendance record. And take a note that the date that we have presented here is June 22nd. We will see it in a bit. And with the command, you can simply list all the employees in the database. We have 13 employees, and we can even add a user so that when I present in front of your factory, in front of the door of your factory, I can just walk in. Okay, so let's log into the back end. And actually, this password is not the password that you have obtained anywhere else. And you see the June 22nd. This is the fake attendance record that we have just added. And all right. Next slide. Yep. So for the convenience and for sake of to make everyone happy, we have written a retrieve employee pictures.py that logs automatically for you and dumps get a token for you and download all the pictures. And of course, the pictures are generated by this person does not exist.com. So we did everything we can to not violate any regulations. So here is the vendor's response. Luckily, we have contacted with the vendor, and the vendor said that they are going to release a GDPR compliance update in August. And this one is from vendor A. Our apologies that we have kind of miscalculated the disclosure time. So in order to make a responsible disclosure, we are not able to disclose the name, and we're not able to talk about the technical details of the vendor A. And however, we still want to talk about it because it introduced a very, very special network topology that we can see. Next slide. So actually, this is a very special network topology among all the face recognition devices that we have seen. And this represents sort of weaknesses or weak points that you can find in other edge computing devices, not limited to access control devices. So on the left-hand side, you see a terminal that's Samsung Galaxy Tablet A. So Samsung Galaxy Tab A is a very high-end tablet running Android 8.1. And however, it's only served here as a terminal and a camera. All the computational power is not used in this case. And in the vendor's original document, we see that the terminal can be a one high-resolution webcam and one TV. So it's not limited to Samsung Galaxy tablet. And the edge server is actually a Dell Precision 3430. That's a very high-end server, workstation. And it does all the detection, recognition, and recording audition in that server. And the thing we have noticed is that it communicates with third-party APIs with an open API interface, and it has a network relay with this device management thing. That's pretty interesting because when you see the network relay, you may think, okay, so how to trigger the network relay to make it open the door for us? And that's exactly how what we have done. And I wanted to emphasize that we have purchased a standalone model instead of a cloud model, so that everything is in HTTP. This has brought us quite a few advantages when we did this analysis. However, you still have to deploy a network relay in your local access network, which means they are still exploitable even if you're using the cloud model. So this is the network access relay introduced by the product's user manual. There are only two types of access relays supported. The one on the left-hand side, the HT-2D, and the one on the right-hand side is a very common access relay that does. So it takes an Ethernet input. So with RJ45, you can just send commands over UDP port 5000. And with one single command, like ON1, the output 1 is turned on, so it's shorted. And then you can you can open the door. And actually, this is what we have deployed in our office. So you see this wooden board with a very big hole, and you see the very friendly USB-C cable here. It's connected to the Samsung Galaxy tablets. It provides power to charge the tablet itself, as well as providing a network access, which means the tablet is not accessing the network via Wi-Fi, but via this actually wired network access. So the thing that I have done is to just, plug that USB-C cable to my MacBook and then I get what I want, the local access, local area network, and I am in the local area network. And then what I've done is to use ping to try to probe what's in the net, and then I found some interesting IP with port 5000. So let's see. With one single command on one to UDP port 5000, the door's opened. The interesting thing is that I cannot close the door, and I didn't wear a uniform, and I was standing there asking a colleague of mine to take the video for me, and nobody has asked me any questions. So, yep, the next one. Luckily, we have contacted with the vendor in this case, and the vendor's response is that they have a manual workaround that their technical support personnel can help their customers to deal with. And this series is no longer there. is end of line already, and in the new series, they have introduced security measurements to prevent this kind of open the door. And they have already published a public advisory to customers. At least I have seen the Chinese version. Maybe there will be English version pretty soon. And the vendor has promised us to fix it and gradually deploy the fix to all other models within 1 month. So applauses to them. Well, it's a very good reaction of this vendor. So let's do a very quick summary.
All right, so I'll be doing a very quick summary here. So although we were attacking access control devices throughout this talk, some cybersecurity must do are shared by all edge computing devices. So here we managed to identify three particular types of attack. So one is the implicit trust of devices, communication between server and devices, and actuator. So looking at the table here, ZK is the most unsecured, but they've recently updated their firmware, which is now using HTTPS. That's a good thing, but still, I was able to execute my script using HTTPS, and I was able to create my own user again.
Okay, so this is the matrices of the responsible disclosure. Our apologies again that we have miscalculated this vendor A's close date, so that actually in 3 days we're able to disclose everything. And if you download the slide in 3 days, you will have all the details that we have promised. And even though ZK Tackle has responded to our inquiries, they did not respond to our follow-ups, and they didn't tell us if they have fixed anything. So we have no choice but to open it as a 0 day. I mean, to disclose it as a 0 day. And for Telpo, even though we have contacted with Telpo people, unluckily, they did not work with ZDI, and we have no other choice but to disclose it as a 0 day as well. And for vendor A, thanks for this cooperation, and we will disclose it in 3 days.
All right, thanks for that, Phil. Well, for some notable SNAFUS, so we have 4 devices, right? One of our findings is that devices and servers should always communicate using HTTPS or any secure communication protocol, like TLS or anything with the certificate. Additional authentication layer and not just serial number should be used to harden the communication authentication. Okay, communication between server and devices should always be encrypted. So looking at the 4 devices, well, it's there, right? Okay.
Okay, so takeaways. Maybe you can notice that these vulnerabilities are actually not new. And in fact, they have been documented for years. And for example, if you just check the OWASP top 10 vulnerabilities, you see many of them are applicable in our examples. So first, for example, the lack of encryption by default. We have seen HTTP instead of HTTPS in many devices. And second, encryption disabled at server side. Yeah. And third, broken authentication and session management. For example, in Telpo, it's a broken authentication. We can just use the serial number printed on a label to get access to everything. And then vulnerable components. So actually, the edge computing devices has brought a very powerful computational power and gave us a very good, very convenient, very resilient devices. in the deployment. And however, a greater caution is needed to deploy such devices in a secure way. And last but not least, I want to say that for particularly for edge computing, the upper layer must not blindly trust a middle layer, just like the examples that we have shown in this presentation. And at least if anything is hackable, you have to make the access logs auditable so that in the end of the day, you know who has hacked you. So thank you for attending this talk, and Roel and myself are on the live stream questions. Just go to Hack in the Box Discord channel. We will be there answering your questions. Thank you, and have a good evening.
Thank you, guys.
Cool, thank you. Yeah, there aren't any questions on Slido, so I'm guessing they're keeping them for you at the Discord channel. One question I do have for you guys: is it your opinion that things are at least improving with these sorts of devices? That the security implementations provided by them, at least they're getting better?
Well,
hard to say right now, actually, since we have this pandemic issue, so we haven't had access on different access control. But probably looking at the transformation of access control from fingerprint biometrics to facial recognition with the additional of temperature control. Well, the functionality of the device is kind of okay, but security-wise, communication, still a lot of things to check on that, actually. So it's too early to actually say, to say that it's really okay right now or not.
Okay, I'm mentioning it because I've seen recently, you see a bit of an uptick on, like, let's call it generically IoT devices that some legislation is also getting in the way of them reaching the market now. Like, a device has to be properly securable. I was hoping that potentially these devices would similarly get some attention and some love by their vendor. Okay, so guys, thank you very much for your talk.